Hi guys, today Raghuvamsi, Chad Vijay and Manglendu Jha will teach you about number systems. Today we'll learn numbers, number systems, different types of number systems, their applications and conversion of a number from one number system to another. Numbers. A number is a mathematical object used to count, measure and label. The original examples are the natural numbers 1, 2, 3 and so forth. A notational symbol that represents a number is called numeral. In addition to the use of counting and measuring, numbers are often used for labels, as with the telephone numbers, for ordering, as with the serial numbers, and for codes, as with ISBN. In common usage, number may refer to a symbol, a word, or a mathematical abstraction. So, in olden times, we used to count with fingers. Then we came up with tally, like lines, and then after that glyphs, and then finally we are here with a good representation of a number. Number systems. A number system is a writing system for expressing numbers, that is a mathematical notation for representing numbers of a given set using digits or other symbols in a consistent manner. There has to be something common to them. It has been seen as the context that allows the number 11 to be interpreted as a binary number for 3, the decimal number for 11, or a symbol for other numbers in different bases. The number system represents is called its value. Ideally, a number system will represent a full set of numbers, that is all integers or rational numbers. Give every number represented a unique representation, or at least a standard representation. Reflect the algebraic or arithmetic structure of the numbers. Then different types of number systems. Binary, that's the base 2. Every counting is done either 0, 1. Octal systems, base 8. The numbers are from 0 to 7. Decimal system, that is base 10. The numbers that we commonly used in our everyday lives. And hexadecimal system, base 16. It has 0 to 9 and other letters like A, B, C, D, E and F.
Decimal system is of base 10. The decimal number system, also called the base 10 position numerical system and occasionally called denary, is the standard system for denoting integer and non-integer numbers. It is the extension to non-integer numbers of Indo-Arabic numeral system. The way of denoting numbers in the decimal system is often referred to as decimal notation. Decimal numbers are a sequence of digits from a set of 0 to 9. Binary system. In a computer, information is stored using digital signals that translate binary numbers. A single binary digit, 0 or 1, is called a bit. A single bit can represent two possible states, on 1 or off 0. The combination of bits is used to store and represent different values. Group of 8 bits is called byte. Group of 4 bits is called nibbles. In base 8, we are limited to only 8 digits, 0, 1, 2, 3, 4, 2, 7. There are no such things as 8 or 9. We count the same way as we normally would, except with only 8 digits. Applications. Binary. Switch on off. When it is on, it is treated as true. When it is off, it is treated as false. Many integrated circuits use them in logic gates. This is the machine understandable code. When we use an instruction to computer, it cannot perform normally. It converts our instruction into some sort of code again. Instructions are converted into American Standard Code for Information Interchange values. They will be converted into binary codes. Octal system. For some purposes like Unix file permissions, group of 3 bits are semantically important, and it makes more sense to use octal to show those grouping by 3 bits. Hexadecimal number system on the other side are used in microprocessors and microcontrollers, where they can input as hexa numbers, process it by converting them into binary, store it and display the same in hexadecimal. In web development, the CSS color can be given in hexadecimal formats. These numbers give us wide range of advantages in data science field, artificial intelligence and machine learning if we need to identify each sample of data from billion of data available. Hexadecimal number will be lessen the load of creating small IDs than with decimal numbers.
Hi guys, I'm Raghuvanshi and I'm going to explain the conversion of numbers from one base to another. So far we've learned that binary has base 2 and uses digits 0 and 1. Octal has base 8 and uses digits from 0 to 7. Decimal, which we use in our day-to-day lives, has base 10 and uses digits from 0 to 9. Hexadecimal has 16 and uses digits from 0 to 9 and the letters A to F. Now I hope you all learned that A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. Now decimal to octal. Now the easy way to convert a decimal number to an octal number is by keep on dividing it by 8. Now when we divide it by 8, this is the number this is the remainder which you get. We set the remainder aside like this and we keep on dividing it to the last number, to the last remainder. Now we write the remainders here, all of them in a step by step over here, and after the division is done completely till we get the last remainder, then we write the octal number as this from bottom to top, which will be written as left to right. As you can see, we divide the number 1, 2, 3, 4, 5 with 8, and we get the number 1, 7, 0, 0, and finally 3 as the remainder. From this we can say that the number 1, 2, 3, 4, 5 presented in decimal system can be written as 30071 in octal. Now decimal to hexadecimal. Now as you can see here, 10 is equivalent to A, 11 is equivalent to B, and so on. In hexadecimal also, it's pretty much the same thing. We just keep on dividing it with 6 and note down the remainders and write in the same way. In case we get a number in remainder, that is 10, 11, 12 or till 15, such an example here we got 13, we write that as D, and hence over here the number is 2D5. Remember, bottom to top will be written as left to right. Now decimal to binary. Now this is the same thing and this is not complex at all, it's just a bit lengthy. Keep on dividing it with 2 and write the remainders exactly the way they are. Bottom to top will be written as left to right. Okay. Octal to decimal. Now say the octal number is written as this. Okay, so this is in the units place, tens place, hundreds place, thousand and 10,000. Now this is the octal number and we need to convert it to decimal number. So we need to remember one thing, that in any system, it's the units place. To convert any system into decimal system, we have to multiply the number in the units place with the basis power to 0. This is units. This is considered as 0. 1, 2, 3, 4. So 6 into 8 power 0, that's 1. So 6 into 1 is 6. 4 into 8 power 1, that's 32. We keep on going like this, and then we add up the whole thing, and hence we get our final number in decimal form. So here we use 37246 in octal as an octal form, and when we transform it into a decimal system, we get 16038. Similarly, in hexadecimal also we do the same thing. So we multiply the units with 16 power 0, then 10 with 16 power 1, and so on. Now remember, all the letters represent the double digit numbers 10 to 50. A to F represent 10 to 50. Same thing here. Now hexadecimal to binary. Now say that the number hexadecimal is 5F. Now we take these digits apart. All the digits present in the hexadecimal format, we write them separately and write each of them in the binary form. So F is 15. Now 15 can be written as 4 ones. 5 can be written as 0 1 0 1. Now this is written like this, and we just join them together and write them together, and this is the binary form we get. Now if we convert this into decimal, we just get 95. So yeah. Similarly, like in a hexadecimal, we converted these into binary and wrote them together. We do the same thing in octal to binary. We convert them into binary and write them together and do the same thing.
Now, binary to hexadecimal. See, to convert a binary number to hexadecimal, we simply write the number down like this, okay? And if we're converting to hexadecimal, we need to group it in groups of 4, okay? From right side. So right to left, 0, 1, 0, 1, 0, that's one group. Then 1, 1, 0, 0, that's one group. And 1, 1, 0, 1, that's one group. Okay, now when we group these up, write them down in the number form. How they write them down like this. So this 0 1 0 1 is actually 5. 0 0 1 1 is actually 3, and 1 0 1 1 is 11. So in hex form, it's B. So B35. Now in case we get, instead of the 0 here, we have a 1 here, okay, and then instead of this 1 there's nothing. So then we group up 3 of these, right? We get 111 over here. Then to make it a group of 4, we just add a 0 over here and write it down. Simple as that. Now binary to octal is pretty much the same thing as binary to hexa. Over here we took groups of 4, and over here we take groups of 3. Now easy way to remember this, octal is 8. 8 is a 2 power of 3, so 3, right? And hexadecimal is base 16, and that is 2 power of 4. So that's why over there we take groups of 4, over here we take groups of 3. So we divide it up into groups of 3 from right to left. 3, this becomes 4, this becomes 7, this becomes 100, this becomes 2. Oh sorry, this is 5. And that's it. Also, one more thing. Now this is an easy diagram to understand. This can help you figure out how to convert one thing from another. Now a decimal base number can be converted to binary. Now from binary you can convert it to hexadecimal or octal, or you can even convert it directly octal to hexadecimal. Now we just showed you how to convert a binary number to octal and also a binary number to hexa. Similarly, we also shown you before how to convert a hexa to binary and octal to binary also. And in the beginning we already taught you how to convert decimal to octal and octal to decimal, and similarly hexa to decimal and decimal to hexa. Thank you.